let's solve the today's daily problem. And what it states that we are given a string. We can perform two operations on it. Either we can add a number to the odd indices, or we can rotate the string to the right by p positions. And after doing these number of operations n number of times, where n is infinity, we have to tell what's the lexicographically smallest string which we can form. Now at the forefront of it, we cannot like do a brute force on it, even if you think of a brute force approach, you can't simply go around be like, okay, let me do these operations and store it in a queue and then traverse and check the lexicographically smallest one. So technically, even when you're thinking of a brute force in such type of questions wherein you know that the answer is one of the states of your traversal, and especially with strings kind of problems, you have to think that, okay, this is nothing but I have a state, I have certain number of operations which I can do, I can move to a different state, and my answer lies among those states. So BFS DFS graph is your way to go in such kind of problems. So how do we develop such intuition is by practice. Whenever you see such kind of problems wherein okay, you have these number of operations wherein you can move to one state to another state, and similarly from there you can move to another state, and then you have to do some pre-compute or store some values, intermediate values, which finally can be your answer. So I have written the code for it. I'll just explain you and walk you through this. So normal VFS construct, this intuition is the hardest part to get through, but once you get this normal BFS approach, we have a queue and a visited array. We add the string to the queue and the visited array, and normal BFS we check while the queue is not empty, we extract the current string, we compare it to our smallest which we have maintained, which is kind of a running answer, and if the current is lexicographically smaller, and how do I check that is I have a compare to function in Java in which I can do the current string dot compare to some string, and if the value is negative, that means this is smaller. If it is equal to 0, that means they are equal. If it is positive, that means this is greater. So if it is smaller, we update our smallest. Now we have first operation, which is nothing but we have to update the odd indexes. So what we do is we maintain a character array of the given string, and how we do that is 2char array in function is a Java. In Java we do have this 2char array, and then we traverse through this, and what we check is current I, whatever that digit, it would be from 0 to 9. How do we get that is subtracting minus 0. So how technically it happens is that its ASCII value is subtracted, so technically we get the digit itself. We add a, and since we have to take a modulo by 10 according to question, because after 9 it has to come to 0, so we take a modulo by 10, and then we again add plus 0 to get it to a char. So we can get one string by new string of this character array. Then we have a rotated array in which what we do is we can simply take substring, and we do know the substring, it takes a begin index and it takes the end index. If we do not specify the end index, it will simply prolong it till the very end of the string. So since we have to rotate it by b, that means like if we have 3 4 5 6 and b is 1, what happens is that 6 comes forward, right, and then 3 4 5. So this is what we have written. We have taken a substring of n minus b, that is n was 4, 4 minus 1, that is 3. So takes a substring from this index 6 till the very end, plus we concatenate the remaining part, that is starting part, which will be nothing but 0 till n minus 3. Simply we check if it is already there. If not, we add it and we return it. So that's the basic intuition of this problem. So we can also learn certain aspects from this problem is that, okay, so if we have this, how do you calculate substring? So this is a bit interesting, that if you have a string, you can simply do is that we can have a string temp be nothing but s dot substring of your current string, and current string we have, if you see, like if I give an index 0, so it takes begin index and then it also asks for an end index, let's say 3. So this will be 0 1 2 3. So what can be the output? So you can pause and just think what will be the output of this. Okay, so if simply move forward. So we know that 0 1 2 and 3, so we have given 1, that is 2, and index is 3, so 2 and 3, right? So if you just run this, you can see that the output will be 2 and 3. Okay, this is your end index. What will happen if I remove this? So this will be simply giving you 2 3 4. So this is your s.substring. So that's one thing which you can pick up from this problem. Another construct is how do you identify the BFS. Okay, BFS has a very simple standard template in which you maintain, first step is you maintain a queue, then you maintain a visited array, and then while your queue is not empty, what you do is you check that current string, what is the current string, and then you do the operations on this and check if processed. If not, you process it, else you do a continue. So this is a simple BFS construct, and some string manipulation concepts are required. So fairly easy to medium problem, I'll say. Alright, thank you.